All right, welcome back. 22.4. The Helvell-Zelinsky reaction, or HVZ for short. All right, this is the reaction in general terms of a carboxylic acid with alpha protons under conditions that result in bromination. We need Br2, but we're also going to need PBr3, okay, because we saw for ketones that the enol form was not highly favored, and for all the other carbonyls it's even less so than the aldehydes and ketones. So carboxylic acids don't tend to form significant quantities of enol. So we use the PBr3 to convert it in situ, that means in the reaction, in glass, into the acid halide. Now, this has much more of an enol tautomer accessible than the carboxylic acid. And so that's the first step. Then the second step is water. And water, of course, you know, hydrolyzes acid halides, and particularly bromides, which are the most reactive. We can make chlorides and bromides. Those are the most reactive and very rapidly will hydrolyze back to the carboxylic acid. So this can be very useful. Let's look at a specific example and then we'll look at the new mechanism. So if we had phenylacetic acid, I don't have to say alpha phenylacetic acid because there's only one carbon that it could be attached to. We treat this with first PBr3 and then Br2, and then after that reaction is complete we add water and allow it to hydrolyze. Then we get the alpha bromo compound, and we get this in the same way that we did, we get monobromination just like we saw for the acid catalyzed reaction of ketones and aldehydes. All right, so now how does this work mechanistically? We've already discussed the formation of the acid halide, and of course with, let me just take a simple one here. Once we've formed the acid halide, this is in equilibrium with its enol form. And even though that's not as favored as it would be, say, with other systems, there's more than enough of this that, again, when bromine is present, we've got a very nucleophilic alkene that attacks the bromine. And then water, and we already studied that, but maybe you should push the arrows if you need a little bit of review there to get back to the carboxylic acid. And so these are useful derivatives, these alpha bromo compounds, because of course you could imagine with the right amine source, workup, you could displace that. These are very good electrophiles. They're very suitable for SN2 type displacements. And of course, this is an amino group at the alpha position of a carboxylic acid. Where do you find those? Alpha amino acids and all the amino acids in biology and the proteins and enzymes in your body. Right, so that's an alpha amino acid. Okay, so these are very, very useful chemistries to know and use and apply.